Alright, we're going to be testing the Power Save model 2201, and here's the unit right here. This was actually installed about a year ago. And here's the panel. We got our power quality analyzer right here, and I'm hooked onto one of the incoming 120 phases, and there's my leads on the two buses, the hot buses, and I'm gonna get some light on this display. As you can see, we're running 5.4 and some change on the kilowatts. Now I'm going to hit this breaker right here, which is what goes to the supposed power saver, and we're going to see what happens. Okay, I just flipped the breaker on, and I am not observing any changes in the kilowatt consumption. If anything, I'd say it went a point or so higher. Let me turn it back off. Hey, look at that, the kilowatt consumption went down. Now remember, your power meter that the power company bills you on measures your kilowatt consumption, not your kilovolt amps, which is shown right below. Power save unit is on. Off. See, I'm not seeing any real changes here in kilowatt usage. I'm gonna go ahead and turn it back on now. Look at that. Actually, the usage just shot up a little bit, not much. Off. See how the kilowatt consumption went down with the unit off? Now we're going to turn it back on. Oh, look at that, it went right back up. So this thing is not saving any power. In fact, it's consuming a tiny bit of power. Not much, but certainly not saving anything. It's actually slightly increasing it, although by an almost imperceivable amount. We're talking maybe $1 on your power bill, but it's actually making your bill go up, not down. Now if you look at the second line from the bottom there, it says PF, that's our power factor. It is actually quite good, 0.994, that's almost perfect. I'm going to go ahead and turn the unit off, and it actually did go down a little bit, so the unit in this particular case, with the loads we have running right now, is correcting the power factor and making it better. Now I did this same test about a year ago when I first did put the unit in, and there wasn't many loads running, and it actually made the power factor flip over to the positive side, and it was actually lower. It changed over from an inductive power factor to a capacitive power factor, and the number was actually lower on the capacitive side, which means it got worse. But in this case, we've got the air conditioning running, I've got the dryer running, you might be able to hear it in the background. I've got every single ceiling fan in the house on, so we're pretty much running every inductive load that we can right now. And when you have everything going, I just turned it back on, when you have everything going, it does actually slightly make the power factor a little bit better. As you can see, when I just turned it on, it went up a little bit. Now I'm going to turn it back off. And you'll see the power factor jump from 0.98 to 0.93, so when I turned it off, the power factor did get a little worse. But the important thing to note here is up at the top line, that's the line that determines how much the customer is being billed, is our kilowatts. Not kilovolt amps, which is right below it, but kilowatts. The meter can tell the difference between kilowatts and kilovolt amps. And you'll notice that when I shut the unit off, like I just did, the kilowatt consumption went down. And when I turn the unit back on, like that, it just shot up a tiny bit. So in fact, it's actually costing people money. It's not saving money, it's costing them money. I hope this will put a nail in the coffin on this debate, because I keep seeing it come up on the internet over and over again. So this is undeniable proof. We have the unit, we have a power quality meter, and an actual real-world test, and it does not save any power. In fact, it actually consumes a little bit.